Welcome to my first presentation on securingthestack.com. I'm Zach Roof, and essentially today we're going to be talking about exploiting web applications, right? And how the bad guys are making that paper, right? And so, as any person who loves to research, right, you obviously do a little background, okay? And so for my, presentation that I'm doing today, hey, I looked, I kind of asked the Google bot, hey, who's making that paper? And the Google bot came back and this is what he or she said, right? Right? So if it don't make dollars, it don't make sense, right? And clearly this lady knows something about making that paper because hey, she's even got paper hair. Uh, but I think what this kind of shows, right, is wow, I'm surprised. I mean, even the Google bot doesn't know the full story of who's making that paper, right? And that's kind of the crux of today's topic, right? It's essentially looking at how our application business logic, right, as developers, is being exploited for profit. And before we go further, I'm just going to give you a brief background on myself. And that's only because this is kind of the first presentation on securingthestack.com and just for you guys to get to know me a little bit and my background so you could, reach out to me if you need and yeah, and just kind of go from there. So let's go. Who is this guy? All right. Work. Okay. I currently work at a company called Benefit Focus, and I essentially do or have done, Node and Backbone. Kind of, gone from Node to a little bit more Backbone, so I kind of pivot between the two. Okay, and freelance, right? I've done some Ruby on Rails development, Amazon Web Services, and Node, MongoDB. So that's kind of where my technical skill set is. All right, so let's start thinking about our problem background, right? And kind of the crux of what we're talking about today. And essentially, here's kind of where we're going, right? Is that hacker human logic. And just kind of pause right now and you can kind of think about what are some basic tenets, right? Fundamental tenets of human behavior. Okay. So for me, I really think that that has to do with just the path of least resistance, right? We are biologically pre-programmed to go with the path of least resistance, right? And that includes, okay, hey, where's the lowest hanging fruit, right? And that's not even a bad thing, right? Like as programmers, right, or developers, or whatever the trendy word is now, it's we need to be lazy, right? Because that's efficiency, right? So where's the lowest hanging fruit? Now, a little bit of an example of this is the Nigerian scammer example, and I love peering into that spam box on my Gmail account every once in a while, and kind of going through the jungle, right? And I'll see a lot of these emails from our dear friends, and I'm sure what all of you have too at some point, but. Anyhow, it usually goes something like this. Our dear friend King Mabutu is stranded in customs, right? Say at JFK Airport or something like that, right? Oh, no, right? See, I kind of messed up on my pronunciation of that. I should have hit a little bit of a higher note, but hey, you can sub that in here, right? So, okay. But if we give him 5K, bam, we'll inherit the throne, right? So, I mean, that sounds right up my alley, right? So here's the gig, right? I mean, why are these scammers that bad? And that's something that I've thought about a lot in my life. Whenever I've seen these types of emails, it's like, God, are these guys this dumb? Right? I mean, are they? Well, actually, they're quite smart and they want the lowest hanging fruit, right? These are scammers, right? I mean, and they're humans in general as well. So what that means is, I mean, for me, right, that lowest hanging fruit is they only want the most gullible, right, to minimize time cost. So if you think about it, like these guys go through their scam and they're interacting with somebody and, go, 5, 10 email exchanges in, right, and the person backs out at the end. Well, hey, I mean, that's very costly, right? So, actually, I mean, and I have heard different cybersecurity professionals talk about this, and I used to think, oh, wow, are these guys this like silly? Like, why don't they make it a little bit better? No, they're actually, this is all part of the scam, right? So, kind of an interesting thing to, keep in mind as we move forward. All right. So, let's start thinking about our problem background, okay, a little bit more. So, kind of think to yourself, okay, and you can always pause the slides at obviously any point just to kind of reflect. And I do a lot of reflection kind of things in just all of my presentations going forward because I think that's very important to reinforce learning. So, what component of a web app do hackers usually target, right? So, for me, it's, you can think of it another way. What kind of information will maximize their profit? Boom, the database, right? And why? Okay, because you have credit cards, social security numbers, etc., right? So what we're going to do is really from here, just take a little diversion for a second and just look at a traditional enterprise level architecture or just a traditional web app architecture and see how one would get to the database, right? So let's check that out. So here's a little architecture aside. So essentially we have n-tier architectures in web applications, right? And this is three-tier in this case, right? So one, you can think of this as 1, 2, and 3, right? Just from the server side, we're just looking at that from that perspective, right? And you usually have the presentation layer, right? And that's essentially, the web server that the browser's connecting to and is serving up content, right? Then you have the application server, right, with our business logic, and that's something that we're going to be speaking about very in depth today. And then you have the data layer, right, and that's the database. So something that I really wanted to, speak about today, and it's very important, is this red thing right here, right? And it's the IDS or the intrusion detection system. And essentially what that is actually we're going to go into that on the next slide, so I won't spoil it right now. But this is kind of a heads up of just the traditional architecture. But I guess the main gist of this slide is every single time a person they have to go through the firewall, and they're going through all of these layers, you can kind of think of it as a permissions funnel. Okay, and that the permissions are getting more and more granular, right, as one progresses to the database. Okay, so yeah, I mean, around those permissions, right, there's other types of, one of the still, most widely used, exploits is, say, MySQL injection, right? And that's kind of a way to get around some of all these different permission guards, right? But as we'll see, that's being mitigated more and more by these intrusion detection systems, right? These IDSs. And we're going to go into that. But just kind of think about from this perspective, I mean, this is a lot, to kind of go through. And these intrusion detection systems, okay, are actually going to be pretty much they're getting better and better at blocking certain types of traffic. So the cost of getting into the database and exploiting that for profit, it's starting to increase. And we're going to kind of talk about these IDSs and how they're kind of progressing in the next slide, and you'll kind of see how it's the database is no longer kind of the lowest hanging fruit. It never truly was. I guess the lowest hanging fruit in relative to profit. Okay, that's how we can think of it. So, all right. So what is an IDS, right? So you can think of it as a device or software app that monitors traffic. Okay, so you can kind of think of the firewall, right, as blocking certain traffic on certain ports or allowing it, right, like allowing port 80, right, and allowing 443 for HTTPS traffic. Okay, but the IDS you can think of as the intelligent monitor of that traffic. So the firewall and the IDS kind of work together. All right. So there's a couple of different types of IDS systems, okay, or IDSs, okay. You have the statistical anomaly base, which is just a fancy word for just saying that, hey, traffic that's coming in is vetted against a baseline, okay. And essentially, the bandwidth, the protocols, what ports are used, et cetera. Basically, it's monitoring that and it's establishing a normal baseline. Okay, and after that normal baseline has been established, all traffic into the future is kind of looked at that and says, hey, is it was within a standard deviation or two of the norm, and that's kind of what goes on in that version. Then there's also signature based, right? And signature based is, something that we can think of it as essentially pattern recognition of known exploits. All right. So basically IDS systems have, a database or just a repo of just common exploits and the code, signatures or just code snippets, right? Of kind of that, that bad code. And then, the code that's coming in, it's looking at that, right? And it's saying, hey, does this match these common exploits? If so, we can actually, the IDS in certain types of architectures can talk to the firewall and say, hey, block traffic from this individual and so forth. Okay. Now, things that escape IDS, right? So let's think about that. All right. Traffic that is within the baseline, okay, and traffic that has a high degree of variability, right? And that because hey, if it's variable, then it's not going to be in that database of those known signatures. Okay. So where's the fruit, right? So essentially, where's the fruit, man? So as IDSs become more efficient, right, that they're being utilized, with I mean the technology behind them is starting to really pick up. Okay, hackers need to start looking for uncommon ways to get the lowest hanging fruit. Like IDS systems are starting to pick up, SQL, SQL injection, right? A lot easier. And so a lot of these things are becoming more difficult for, for kind of, for hackers to get in, right? So we need to start thinking of uncommon ways, to get the lowest hanging fruit. And essentially, where is the lowest hanging fruit, right? That's essentially the question. Okay, where is it now? Okay, boom, it's an application business logic, right? And that is basically the crux of what we're talking about here. So for this week, I'm just going to pause right here, and we're going to go ahead and pick it up next week. And but I think this is just kind of a natural spot to kind of stop. And I'm looking forward to seeing you guys next week. Okay, all right, take care.